Hey guys, in this next lesson I want to continue talking about multiplying polynomials. We're going to talk about some special cases in this video though. And those special cases are going to involve you learning some special rules that will allow you to simplify certain polynomial multiplication problems, and once you get good at them, they're going to actually become shortcuts for you. Okay? So there are two rules I want to look at. The first rule is what's called the square of a binomial. So when you take a binomial and you square it, it's going to be written like this. Okay, this is what a binomial squared looks like: the quantity a plus b squared, or the quantity a minus b squared. And the result is this here: a squared plus 2ab plus b squared, or if you have a minus, a squared minus 2ab plus b squared. And in English, this rule says this. It says that the square of a binomial is always equal to the square of the first term plus or minus, depending on the problem, twice the product of both terms plus the square of the last term. Okay, so the square of the first term plus or minus twice the product of both terms plus the square of the last term. So down here in examples 1 through 4, we're going to use that rule for each of these squaring binomial problems. So number 1, I have x plus 8 quantity squared. One of the most common mistakes I see in algebra are students telling me that the answer to this is x squared plus 64. Okay, because they're trying to square the x and the 8, and they're forgetting that there is always a middle term when you have a problem like this. So this would not be correct. X plus 8 quantity squared means the same thing as x plus 8 times itself. So if you think about writing it like this, you can see that you're going to have to use FOIL on this. X times x would be x squared. X times 8 would be 8x. And then you have another 8 times x, so you have another plus 8x. And then finally 8 times 8 is plus 64. So you end up getting, if you use FOIL, x squared plus 16x plus 64. Well, we can get the same thing using that rule that I talked about up here in the box. Okay, so that rule says I do the following. Okay, I take my first term squared plus twice the product of both terms plus my last term squared. Okay, so that means I'm going to take my first term, which is x, and square it. X squared is just x squared. I'm going to take the product of my two terms. The product of x and 8 would be 8x. Twice that, times 2, would be 16x, so plus 16x. And then finally, I take my last term, which is 8, and square it. 8 squared is 64. So if you're using that rule up there, you do get the same thing, x squared plus 16x plus 64. Okay, so we're going to practice using that rule now for each of these examples 2, 3, and 4. So for number 2, we have the quantity n minus 7 squared. So my rule says, because this is a subtraction problem, the answer is going to be the first term squared minus twice the product of both terms plus the second term squared. Okay, so your first term is again x, or excuse me, in this case it's n. Your first term is n. The product of your two terms, n and 7, would just be 7n, and then your last term is 7. So the answer to this would be n squared minus 2 times 7n is 14n plus 49. Number 3, we have 2m minus 3 quantity squared. Again, square root of the first term minus 2 times the product of both terms plus square the last term. Okay, that's how we set up this rule here. Your first term in this case is 2m. The product of both terms, 2m times 3, would be 6m. And then your last term is 3. So 2m squared would be really 4m squared. You have to remember your product rule. You have to take the 2 squared and the m squared. So that gives you 4m squared. 2 times 6m is 12m, so this becomes a minus 12m. And then finally 3 squared is 9, so this becomes plus 9. So 2m minus 3 quantity squared gives you 4m squared minus 12m plus 9. Okay, last one, 2x plus 9 quantity squared. Using that same rule, square the first term plus twice the product of both terms plus square the last term. My first term here is 2x. 2x times 9 is 18x. And your last term is 9. So 2x, that product squared, is going to give me 4x squared. 2 times 18 is 36, so this middle term will become plus 36x, and then 9 squared is 81, so plus 81. Okay, so that rule there is a really nice shortcut for when you're squaring a binomial, and memorizing that rule is going to help a lot when we do the next unit as well. Okay, so that's one rule I want you to focus on. Now we're going to apply that rule to a geometry problem. So number 5 here, it says the figures below are both squares. We're going to find an expression to represent the area of the shaded region using what we know about area and squares. Okay, so to find the area of this shaded region right here, we can take the area of the big square minus the area of the small square. So the area of my big square is just going to be x plus 6 times x plus 6, since the sides have to be the same, or x plus 6 quantity squared. Okay, well, when I use my squaring a binomial rule, we know that becomes x squared plus 2 times the product of x and 6 plus 6 squared, which would be x squared plus 12x plus 36. Okay, so that's the area of the entire big square, x squared plus 12x plus 36. The area of my small square is just going to be this side x times itself, so that's just going to be x squared. To find the area of the shaded region, now I need to take the area of my big square minus the area of my small square. So that's going to be x squared plus 12x plus 36 minus x squared. When you take x squared plus 12x plus 36 minus x squared, combine your like terms, your x squareds actually cancel each other out, and you get 12x plus 36. So the area of the shaded region here would be 12x plus 36. Okay, the second rule I want to talk about is here on the back, and this is called the difference of squares rule. Okay, this rule says if you take a binomial, a plus b, times another binomial, a minus b, you get the expression a squared minus b squared. So what that rule says in English is if you take one binomial times itself, the only difference being the middle sign there, okay, if you have two binomials who have the same exact terms but opposite signs, then you get this expression, the first term squared minus the second term squared. And this is what we call a difference of squares. So let's see how this looks in examples 6, 7, and 8. Number 6, you'll notice we have x plus 9 times the quantity x minus 9. So the first terms are both x. The second terms are both 9. It's just that one is a plus 9, the other one is a minus 9. Well, in order to multiply this out, I could go ahead and FOIL, just like normal. So I could do x times x to get x squared, x times negative 9 to give me negative 9x, 9 times x to give me positive 9x, and 9 times negative 9 to give me negative 81. But when I do that, you'll notice that your middle terms, negative 9x and positive 9x, cancel each other out. So you just end up with x squared minus 81. That is always going to be the case anytime you take a binomial times itself with the opposite sign. Okay? Those middle terms are always going to cancel each other out. So really, all you need to do is take the first term squared minus the second term squared. X squared is just x squared. Subtract 9 squared is 81. You end up getting the answer, x squared minus 81. So let's try that with number 7 here. We have d plus 11 times the quantity d minus 11. This is a difference of squares problem because both binomials are the same with the exception of that middle sign. So if I take my first term, d squared, subtract my second term, 11 squared, I end up with d squared minus 121. Okay, number 8, m squared minus 6 times the quantity m squared plus 6. So our first term is m squared. Our second term is 6. When you take m squared squared, you get m to the 4th. And then 6 squared is 36. So this becomes m to the 4th minus 36. So this rule here is a nice shortcut for when you're taking a binomial times itself with opposite signs, which again is called a difference of squares. Okay, finally in 9 through 12 here, we're just going to use both of these rules, the one from the front, the square of a binomial, and the one we just learned, difference of squares, to simplify these binomials here that have multiple variables in them. So starting with number 9, 5p minus q quantity squared. That is a square of a binomial problem. So we're going to take the first term squared minus twice the product of both terms plus the second term squared. So our first term is 5p. 5p times q would just be 5pq. And our second term is q. When we take the first term 5p and we square it, we get 25p squared. Negative 2 times 5pq would be minus 10pq. And then q squared is just q squared. So 5p minus q quantity squared becomes 25p squared minus 10pq plus q squared. Number 10, same thing. We have a square of a binomial. So we'll square the first term. We'll add the product, twice the product of both terms, and then square the last term. First term is 6a. The product of 6a and 11b would be 66ab, and then your second term is 11b. Okay, so the term 6a squared is going to be 36a squared. 2 times 66ab is going to be 132ab. And then 11b, that squared, is going to become 121b squared. Number 11, this one is a difference of squares rule, 7b plus 8c times the quantity 7b minus 8c. So for this one, I'm going to do the first term squared minus the second term squared. So my first term is 7b. My second term is 8c. When you take 7b squared, you get 49b squared. Subtract, the product 8c squared would become 64c squared. So 49b squared minus 64c squared. And then lastly, number 12 is also a difference of squares. Your first term for this one is g cubed. And your second term is 7h squared. So g cubed squared is actually going to be g to the 6th, and 7h squared squared would be minus 49h to the 4th. Okay, so again, these here are meant to be shortcuts for you, okay, meant to be rules that apply to certain types of binomial multiplication. However, you have to remember that you can only use these rules for these cases here. Okay, for all other binomial problems, you have to go through and do the normal distributing and foiling. Okay, but for these two special cases, square of a binomial and a difference of squares, you can go ahead and use these shortcuts here. If you have any questions over this, as always, feel free to shoot me an email with those questions. And until I see you again, have a nice day. You are all wonderful people. Take care.